standing on an horizontal plane and I sight an object at the top of a mast, let's say this is the object at the top of a mast, this line here, this line object is called the line of sight. And then this is the mast where I sight the object. So we have this as the horizontal plane. The angle of elevation is that angle that is formed between the line of sight and this horizontal. So here, this angle formed here is called the angle of elevation. While angle of depression is this. If I look downwards at an object, so if this is my sight and I look downwards at an object, I am still on top of a mast or a building. So the angle of depression is this angle that is formed between this horizontal and this line of sight. So this angle here, theta, is the angle of depression. And this horizontal is also parallel to this horizontal here. So this angle is also equal to this other angle because they are alternate angles. So if you come across questions involving angle of elevation and depression, you may be asked to find the angle, or you may be asked to calculate the height of the, the mast or the tree or the cliff. You may also be asked to find the distance between the object and the, the tree or the mast. So in whichever way question comes, you should be able to solve using your basic trigonometric ratios. So we are going to be solving using two examples. Welcome to Math Easy. If this is your first time here and you enjoy what you're seeing, kindly support me by subscribing to my channel. Put on your post notification so that when next I post a video, you will be the first to see it. Thank you. And we have our first question here. It says an object is 6 meters away from the base of a mast. So let's say this is our mast. 6 meters away from the mast would be in this form. So we have 6 meters here. The angle of depression of the object from the top of the mast is 50 degrees. Remember that means the object is down here and the man is looking downwards. So we have this. And the angle of depression is here, 50 degrees. Remember we said these two lines are parallel. So this angle here is also 50 degrees. Now we have to find, correct to 2 decimal places, the height of the mast. This is what we have to find, which is going to be h. Okay, now this here is perpendicular to this base. Okay, we have a right angle triangle here with a given angle, one known side and an unknown side. Let's identify the sides of this right triangle. This side facing the right triangle is the hypotenuse. The side facing the given angle is the opposite. And this third side is the adjacent. We are going to use these basic trigonometric ratios, which is SOHCAHTOA. So for the sake of those who do not know what this means, these are the basic trigonometric ratios. We have this for sine ratio, which is opposite all over hypotenuse. This is the cosine ratio, which is adjacent all over the hypotenuse. And we have the tan ratio, which is the opposite all over the adjacent. Now, here, the opposite side is not known. That's what we have to find. The hypotenuse is not known, so that cancels it out. We can't use the sine ratio. Let's come over here. We have the cosine ratio, which is adjacent all over the hypotenuse. The adjacent here is 6, which is given to us. The hypotenuse is unknown, so we can use this formula as well. What about this tan ratio? We have the opposite, which is the unknown side, and the adjacent, which is given to us. So the formula we are going to use to calculate for this, the height of the mass, is the tan ratio. So theta here is 50, so we have tan 50 degree is equal to the opposite side is the unknown, all over 6. So we cross multiply. We have 6 tan 50 degree is equal to h. Let's find tan 50 under our table of values. 6 multiplying 1.192 is equal to the height. Let's multiply. We have 7.152 as the height. Correct to 2 decimal places, the height of the mass is equal to 7.15 meters as the answer. And we have our second question here. I want you to pause this video and see if you can attempt this question. A ladder 15-meter long leans against a vertical pole. Because the ladder is leaning against a vertical pole, it's going to be slanted, right? So we have our slanted ladder in this form, which is 15-meter long. Leans against a vertical pole, so this is our pole, and making an angle of 72 degrees with the horizontal. So our angle can't be here. This is perpendicular to the horizontal. We have our angle here, which is the angle of elevation, 72 degrees. Calculate, correct to 1 decimal place, the distance between the foot of the ladder and the pole. So this is what we are to find. Let's call it x. We are still going to use our basic trigonometric ratios. Going by the appropriate ratio to use here is the cosine ratio because it involves the adjacent, that's the unknown side, and the hypotenuse, which we are given. So let's apply the cosine ratio in finding the distance between the foot of the ladder and the pole. So we have cos 72 is equal to the adjacent x all over 15. We cross multiply, we have x is equal to 15 times cos 72. Let's find cos 72 under our cosine table of values. X is equal to 15 times 0.3090. So we have the value of x, which is the distance between the foot of the ladder and the pole, to be 4.635. We approximate this to 4.6 meters as the answer. If you find this helpful, please do not forget to leave me a comment, like this video, share, and subscribe to my channel. Bye.